nights when
Good morning, students. The previous class we have discussed the various possibilities of the relative positions of two circles. Let us recap the relative positions of the two circles quickly. So, if C1, C2 is greater than R1 plus R2, then the two circles will be like this. One circle lies completely outside the circle. They neither touches nor intersect like this. So one circle lies completely outside the circle. So C1, C2 being the centers of their circles and R1, R2 are the radii. So in this case, if C1, C2 is greater than R1 plus R2, the situations will be like this, and there will be two direct common tangents and there will be two transverse common tangents are possible. So there are total number of 4 common tangents are possible. So this point is called external center of similitude. External center of similitude is the point of intersection of two direct common tangents. Likewise, this is a transverse common tangent and this is a transverse common tangent. The transverse common tangent is a straight line and the two circles lie on the either side. For this line, this circle lies this side and this circle lies this side. So as far as common tangent is concerned, direct common tangent is concerned, so direct common tangent is a line. So the two circles lie on the same side of the direct common tangent, same side of a line. That line is called a direct common tangent. Okay. And if C1, C2 is equals to R1 plus R2, two circles touch each other externally. So there are two circles, they touch each other at this point of contact. So if C1, C2 is equals to R1 plus R2, there will be two direct common tangents, and this point is external center of similitude, which is the point of intersection of two direct common tangents and one transverse common tangent, and this point of contact is called internal center of similitude. And if C1, C2 is lying in between the difference of the radii and the summation of the radii, that is R1 minus R2 less than C1, C2 less than R1 plus R2. So here R1 minus R2 is, it may be R2 minus R1 or R1 minus R2, whichever is greater, it will come first. So if this condition holds, then the two circles intersect, cut each other, and this line is called what? Common chord. This chord is common to both of the circles. Therefore, this is one direct common tangent and this is one direct common tangent. Here, no transverse common tangent is possible. And if you come to here, so if C1, C2 is equals to R1 minus R2, so the line joining of the centers is equals to the difference of the radii. Then two circles touch each other internally. So this is the direct common tangent. So this common tangent is called direct common tangent, and since this point lies outside the line joining of this C1, C2, it is said to be external center of similitude. So if the point lies inside the line joining of C1, C2, it is called internal center of similitude. And the two more remaining conditions are C1, C2. If C1, C2 is less than R1 minus R2, one circle lies completely inside the circle. Okay, and here there are no common tangents possible. So is the condition with another case also. Here C1, for both C1 and C2, the centers are the same. That means if C1, C2 equals to 0, the distance, the line joining of the centers is equals to the distance between them is 0. The two circles are concentric. And what we have understood is that The condition for the two circles to touch each other is C1 C2 is equals to R1 plus R minus R2. If C1 C2 is equals to R1 plus R2, two circles touch each other externally. One circle touches the other circle outside. Okay, and C1 C2 equals to R1 minus R2. If C1 C2 is equals to the summation of the radii, then two circles touch each other externally. So one circle lies completely outside the circle. So here, if C1 C2 is equals to R1 minus R2, the two circles touch each other internally. So one circle lies completely inside the other circle, and the two circles are touching at this point of contact. Here, this is the point of contact, and this is the common tangent, and this is the common tangent. Okay, so let us solve the first Roman of the two questions from the first Roman. So discuss the relative position of the following pair of circles. Here, pair of two circles are given. All that we need to do is to tell the relative positions of them, whether the two circles touch each other internally, or two circles touch each other externally, or one circle lies completely outside the circle, or cut each other. So these conditions. So to discuss anything, actually first we need to do is to find the centers of them, C1 and C2, and R1 and R2 also, radii. So C1 C2 is equals to, we need to find C1 C2. How do we find? We have 2 points, x1 y1 x2 y2. So C1 C2 is obtained through the distance formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square, and R1 and R2. So which condition is holding good? If C1 C2 is greater than R1 plus R2, one circle lies completely outside the circle, they neither touches nor intersects. If C1 C2 is equals to R1 plus R2, then the two circles touch each other externally, one circle lies completely outside the circle. And if C1 C2 is lying in between the R1 minus R2 modulus and R1 plus R2, that is R1 minus R2 modulus less than C1 C2 less than R1 plus R2, then the two circles cut each other or intersect each other, and C1 C2 is equals to modulus of R1 minus R2, then the two circles touch each other, but this time internally, one circle lies inside the circle. And if C1 C2 is less than R1 minus R2, then the two circles, one circle lies completely inside the circle, and so on. So let us see this now. C1 is equals to minus 3 minus 3. So this has to be compared with x square plus y square plus 2gx plus 2f plus c equals to 0. 2g is equals to 6. Therefore g is equals to 3. 2f equals to 6. F equals to 3. The center of the general equation of the circle is minus g minus f. Therefore minus 3 minus 3. And what is the radius of this? Square root of minus 3 square 9 minus 3 square 9 minus c minus 14. So 9 2s are 18 minus 14. So 4 under root, which is 2. And C2 is equals to plus 1 comma plus 2. So R2 is equals to square root of 1 square 2 square 4 minus of minus plus 4. This is equals to root 9, which is 3. So here C1 C2 is equals to distance formula x1 y1 and x2 y2, square root of x2 minus x1 whole square plus y2 minus y1 whole square. So square root of 1 minus of minus 1 plus 3 whole square 4 square 16 plus y2 minus y1 whole square 2 minus of minus 2 plus 3 whole square, so which is 5 square 25. So this is equals to root 41. So here, first of all, what is R1 plus R2? 3 plus 2, 5. So root 41 is something more than 6 point something. 6 point something. Because root 36 is 6, root 41 is something more than 6. Okay, 6 point something. So accurate value we are not concerned about, because we need to mention the relative position, how one circle lies completely outside or not, or touch each other, that we need to discuss. Now C1 C2, R1 plus R2 is how much? 3 plus 2 5. Clearly C1 C2 is lying in between R1 plus R2 and R1 minus R2, because R1 minus R2 is 3 minus 2 1, R1 plus R2 is 5. So this is 6 point something. And now C1 C2 is greater than R1 plus R2, because 2 plus 3 is 5. So root 41, so it is more than root 36, 6 point something. So 6 point something is definitely more than 5. Therefore two circles, one circle lies completely outside the circle. So completely outside the circle, that means one circle is like this and one circle is like this. So this is the condition for the first case. And now come to the second one. So this instead of expanding and come to general equation of a circle, we may do it from here itself also. This is of the form x minus h whole square plus y minus k whole square equals to r square. What is this circle called? This circle is a central equation of the circle with the center h comma k and radius is given. So can you tell me what is C1 here? H comma k. So 2 comma minus 1. This should be compared with x minus h whole square plus y minus k whole square is equals to r square. So in the place of h we may see 2. So y minus k, y plus 1 can be written as y minus of minus 1. So in the place of k, minus 1. So that is the center. And what is the radius? Radius r1 is x minus h whole square plus y minus k whole square equals to r square. R square is equals to 9. R is 3. So r1 is 3 here. And C2 is minus 1 comma 3. R2 is 2. 4 is 2 square. Okay. And now C1 C2 is square root of 2 minus of minus 2 plus 1 whole square 3 square 9 plus minus 1 minus 3 whole square minus 4 whole square, that is 16. So root 25 is 5. Here simply C1 clearly, what is R1 plus R2? 3 plus 2, 5. Therefore C1 C2 is equals to R1 plus R2. So two circles touch each other externally. Two circles touch each other externally. That means one circle is like this and another circle should be like this. So this is what he is asking. What is the relative position of these two circles? These two circles touch each other externally. Now, the second question, find the number of possible common tangents that exist for the following pair of circles. This time, he is not asking the relative position of two circles, how the two circles will be. What are the position of these two circles? Instead, he is asking how many number of common tangents could be possible, for which we need to we need to check for the cases. So how? Solution C1 is equals to minus 3 comma minus 3. The radius R1 is square root of 3 square 9, 3 square 9, 18 minus 14, which is equals to root 4, which is 2. C2 is equals to 1 comma 2. Radius R2 is 1 square 2 square. So that is 5 minus of minus 5 plus 4, which is equals to root 9, which is 3. Now C1 C2 is equals to square root of minus 3 minus 1 whole square, 4 square 16, plus minus 3 minus 2 whole square, 5 square 25. This is root 41. So root 41 is 6 point something. So clearly C1 C2 is greater than R1 plus R2. So then the two circles will be, one circle is like this and another circle is like this. So this is the condition, no? The first condition, C1 C2 is greater than R1 plus R2. Then the two circles lie, one circle lies completely outside the circles. Therefore 1, 2, 3, 4. So therefore how many tangents are possible? There are 4 common tangents are possible. 4 common tangents are possible. So let us solve the next third case of the same question. So C1 is equals to 2 comma minus 1. Radius R1 equals to square root of 2 square 4, 1 square 1, minus of minus g square plus f square minus c, g square 2 square, f square minus 1 whole square, 1 minus c is minus 4, minus of minus. So this is root 9, this is 3. C2 is equals to minus 1 comma 3. Radius R2 equals to 1 square, 1, 3 square 9 and minus 6. 9 plus 1, 10 minus 6, 4 under root, which is 2. Here C1 C2 is equals to square root of 2 minus of minus x1 y1 x2 y2, x2 minus x1 whole square plus y2 minus y1 whole square. So 2 minus of minus 2 plus 1 whole square, 3 square 9 plus minus 1 minus 3 whole square minus 4 whole square, which is 16, which is equals to root 25 5. So here C1 C2 is equals to clearly R1 plus R2, R1 plus R2, because C1 C2 is 5, R1 plus R2 is 3 plus 2 5. Therefore here the two circles will be like this. C1 C2 is equals to R1 plus R2 means the two circles touch each other externally. That means these are the two circles. How many tangents are possible now? So 1, 2. What are these two? These are two direct common tangents and one transverse common tangent. Therefore totally there are 3 common tangents are possible. Common tangents are possible. Now, fifth question is C1 is equals to minus 2 comma 3. Radius R1 is square root of 2 square 4, 3 square 9, minus of minus plus 3. 9 plus 4, 13 plus 13, 13 plus 3, root 16, which is 4. C2 is equals to minus 2 comma 1. R2 is equals to square root of 2 square 4, 1 square 1, minus 4. So 4 gets cancelled. This is 1. So what is C1 C2 now? C1 C2 is square root of minus 2 plus 2 whole square, 0, 3 minus 1 whole square. So 3 minus 1 whole square is root 4, which is 2. Here C1 C2 is C1 C2. Let us see. C1 C2 is equals to R1 plus R2. 2 is equals to 5. No. And C1 C2 is greater than R1 plus R2. So 2 is greater than 5. No. First condition fails. And C1 C2 equals to R1 minus R2. So 2 is equals to 4 minus 1. No. Otherwise, let us see C1 C2 is R1 minus R2. What is C1 C2? 2. R1 minus R2 is 4 minus 1, 3. Yes. 2 less than 3. It follows. That means the two circles will be, one circle lies completely inside the circle. One circle lies completely inside the circle. Therefore, there are no common tangents are possible. So, no common tangents. No common tangents are possible. So, all we are able to, the number of common tangents we are able to express on the basis of the cases that we have discussed yesterday. So, for this, no common tangents are possible. The next question is, find the internal center of similitude for the circles. These two are given. And the fourth question is external center of similitude. I am telling you, internal center of similitude is the point of intersection of transverse common tangents. And external center of similitude is the point of intersection of two direct common tangents. The direct common tangent is the line. So if two circles lies on the same side of the line, the two circles, okay, that line is called the direct common tangent. If the two circles lie on the either side or opposite side, so for example, for this line, if one circle lies here and the other circle lies on the, one circle lies on one side of this line and other circle lies on the other side of a line, then this tangent is called transverse common tangent. And two circles are like this. This is one line. So the two circles lies on, then this line is called direct common tangent. So internal center of similitude is the point of intersection of two direct common tangents. And the external center of similitude is the point of intersection of two transverse common tangents is what we need to find. So let us see this question now. First, C1 of the first circle is minus 3. Simply change the sign and take the half of the quotient of x and quotient of y. That is the center. So here minus is there, take plus and y quotient is 2, half of it. So this is C1. And C2 is minus is there, you take the opposite sign plus and x quotient is 2, half of it, 1. So this is 3. And radius is equals to square root of 3 square, g square plus f square minus c. 3 square 9 plus 1 10 minus 1. So which is root 9, that is 3. R2 is equals to square root of 1 square, 3 square, so 10 minus 9. So 10 minus 9 under root, so root 1 is 1. Now C1 C2 is equals to square root of minus 3 minus 1 whole square minus 4 whole square 16 plus 1 minus 3 whole square 1 minus 3 whole square minus 2 whole square, that is 4. This is root 20. So now C1 C2 is equals to this is 4 point something, because root 16 is 4, root 20 is something more than 4. Okay, and so here C1 C2 is greater than R1 plus R2, because root 20 means more than root 16. So 4 point something. 4 point something is definitely more than 4, 3 plus 1. So C1 C2 is greater than R1 plus R2. If C1 C2 is greater than R1 plus R2, what is the relative position of the two circles? One circle lies completely outside the circle. They neither touches nor intersects. So this is C1 and this is C2. And what is being asked? Internal center of similitude. That means this is one transverse common tangent and this is another transverse common tangent. And this point of contact is what we are looking for. This point of contact. What is this? Internal center of similitude. These are the transverse common tangents. So C1, this is x1, y1 and this is x2, y2. R1, R2 is already there. So internal center of similitude is, yesterday we have discussed. What is that? R1 x2 plus R2 x1 by R1 plus R2, R1 y2 plus R2 y1 by R1 plus R2. So if we want external center of similitude, it will be, this is one direct common tangent, this is another. This point lies outside the line joining of the two centers. This point lies inside the line joining of the center of the two circles. So internal center of similitude plus external center of similitude, formula is same, minus. So see this, R1 x2, R1 is 3 into 1, 3, plus R2 x1, 3 into minus 3, minus 9. Again, R1 x2, 3 into 1, plus R2 x1, 1 into R1 x2, 3 ones are 3, minus R2 x1, 1 into minus 3 is minus 3, by R1 plus R2, 3 plus 1, 6, 3 plus 1, 4, comma, R1 y2, 3 into 3, 9, plus R2 y1, 1 into 1, 1 by 4, that is equals to 3 minus 3, 0 by 4 is 0, comma, 9 plus 1, 10 by 4 is 5 by 2. This is the internal center of similitude. And now this question is similar of that kind. So C1 is equals to 1 comma 3. Radius R1 is equals to square root of 1 square plus 3 square minus 9, which is 1. C2 is equals to A0, 0. Since this is the standard equation of the circle whose center is at the origin and radius is R is equals to, is it x square plus y square equals to R square. R square is 4, R is 2. So now what is C1, C2 line joining of the centers? 1 minus 0 whole square is 1 plus 3 minus 0 whole square is 9. 1 minus 0 whole square is 1. 3 minus 0 whole square, 3 square 9. So this is root 10. Root 10 is 3 point something. Because root 10 is more than root 9. Root 9 is 3. Root 10 is 3 point something. We are not concerned about the particular value of it. So now C1, C2 is equals to C1, C2 is definitely greater than R1 plus R2 only. C1, C2 is greater than R1 plus R2 because 2 plus 1 is 3. So C1, C2 is 3 point something. 3 point something is definitely greater than 3 only. So this time also the two circles will be lying, will be The position of the two circles will be like this only, the relative positions. And this time what we are looking for is this. So these are the two direct common tangents, and this point of contact is called external center of similitude. So therefore, external center of similitude is equals to R1 x2 minus R2 x1 by R1 minus R2, comma R1 y2 minus R2 y1 by R1 minus R2. So R1 x2, this is x1 y1, this is x2 y2, R1 x2. So 1 into 0 minus R2 x1, 2 into 1 by R1 minus R2. So 1 minus 2 minus 1, 1 minus 2 minus 1, R1 by 2, 1 into 0 minus R2 y1, 2 into 3, 6 by minus 1. So minus 2 by minus 1 is 2, minus 6 by minus 1 is 6. Therefore, this is the external center of similitude. The next question, show that the circles touch each other, find the point of contact and the equation of the common tangent at their point of contact. So prior to solving this problem, we don't know exactly as to how the two circles touch each other, because the touching circles may be like this, or it may be like this. So if this is the condition, then if this is the relative position of the two circles, then C1 C2 is equals to R1 plus R2. If the two circles touch each other like this, then C1 C2 is equals to modulus of R1 minus R2. So if two circles touch each other externally, this is the point of contact, and this point of contact is the exterior of the line joining of the 2 points. So therefore here this is the external center of similitude, internal center of similitude. And if two circles touch each other like this, C1 C2, and this is the point of contact, and this is the point of contact, and this point of contact lies outside the line joining of the two centers. C1 C2 is this is the point of contact lies outside the line joining of the two centers. So this is the external center of similitude. If it is if the two circles touch each other like this, then internal center of similitude is R1 x2 plus R2 x1 by R1 plus R2, and R1 y2 plus R2 y1 by R1 plus R2. So in this condition, external center of similitude is equals to R1 x2 minus R2 x1. So R1 minus R2, comma R1 y2 minus R2 y1 by R1 minus R2. So not only he is asking to show the two circles touch each other, so find the point of contact. This point of contact is what he is asking. So that maybe found out by this. And further, equation of the common tangent at their point of contact. So equation of this line, if it satisfies C1 C2 is equals to R1 plus R2, he is asking us to find the equation of this common tangent. Otherwise, if it satisfies this, then this is the common tangent he is asking. How? So we have already discussed it. So this is the circle and this is the point. So this is the equation of the tangent. So for example, this is Px1 y1 and this is s is equals to 0. Then equation of the tangent at px1 comma y1 to the circle s is equals to 0 is s1 equals to 0. So this point which we are going to find out through like this or this, so that point is px1 y1 and this circle. So with respect to any circle you may take, because that common tangent is tangent to both the circles. Therefore, px1 y1 and s equals to 0 may be this or this. So in both the cases, you will get the unique line. So this is how we will do that. So now let us try to solve this problem. Since we have understood the situation, since we have understood the problem, now let us do this. Let us solve this now. Solution. So C1 is equals to 3 comma 1. Radius R1 equals to square root of 3 square 9, 1 square 1 minus 1. So root 9 value is 3. C2 is equals to 1 comma 4. Sorry, minus 1 comma 4. R2 is equals to square root of 1 square 1, 4 square 16 minus 13. So 17 minus 13 is root 4, which is 2. Now C1 C2 is equals to square root of 3 minus of minus. So 3 plus 1 whole square plus 1 minus 4 whole square. So the distance formula I am applying. C1 C2 C1 is x1 by 1 and C2 is x2 by 2. The distance formula. So that is equals to 3 plus 1 whole square, 4 square 16, 1 minus 4 whole square, 3 square 9. So this is equals to root 25, which is 5. Now clearly C1 C2 is 5, R1 plus R2 is 3 plus 2 5. Therefore C1 C2 is equals to R1 plus R2. Therefore, the two circles touch each other is what he is asking us to prove. See, show that the circles touch each other. So, therefore, the two circles touch each other. To be more specific, touch each other externally. That means one circle is this and another circle is this. So in this way the two circles touch each other. Therefore the second case which we have discussed before, this is steer cleared. Therefore it is the two circles are not touching each other internally. They are touching each other externally instead. So C1 C2. Okay. And find the point of contact. So this is the point of contact we are looking for. So this point lies on the line joining of the centers of the two circles C1 C2 internally. That means, so the point of contact is equals to point of contact is equals to internal center of similitude. So this point of contact, let us take let P be the point of contact of two circles. So internal center of similitude P is equals to R1 x2 plus R2 x1. External center of similitude is R1 x2 minus R2 x1. R1 plus R2 comma R1 y2 plus R2 y1 by R1 plus R2. So that is equals to, so R1 x2. So this is x1 y1. This is x2 y2. R1 x2. 3 into minus 1 minus 3 plus R2 x1 2 into 3 6 by R1 plus R2 3 plus 2 5 R1 by 2 3 into 4 12 plus R2 by 1 2 into 1 2 by R1 plus R2 so 5. So this is 3 by 5 comma 14 by 5. So this point of contact we have found this P, and the equation of the common tangent at the point of common contact. So the equation of this line he is asking. Now equation of the common tangent of any circle, because this line is tangent to this circle as well as this circle. So you may take whatever the circle it is. So equation of the common tangent of, for example, I will take S, first circle of S is equals to 0 at the point of contact P. 3 by 5 comma 14 by 5 is S1 equals to 0 is the equation of the common tangent, right? So what is S1 equals to 0 for this? X1 plus Y1 minus, the sign is same, half of the quotient of X, that is 6 by 2, that is 3 into X plus X1 minus of Y plus Y1 plus 1 equals to 0, that is equals to X into 3 by 5 plus Y into, this is X1 by 1 now, 14 by 5 minus of 3 into X plus 3 by 5 minus of Y plus Y1 is 14 by 5 plus 1 equals to 0. This is equals to, LCM is 5. So 3x plus 14y minus 3 5s are, this is 5x plus 3. This is how much? Minus 3 into 5x plus 3 by 5 totally. So LCM 5 gets cancelled. Minus 3 5s are minus 15x minus 3 3s are minus 9. Likewise. And this is minus of, LCM is 5y plus 14. 5y plus 14 by 5. Since the LCM is 5, so minus 5y minus into plus minus 14 plus 5 ones are 5 equals to 0. So the answer is 3x. Therefore the answer is 3x minus 15x minus 12x 14y minus 5y, that is 9y. Next, minus 9 plus 5 minus 4 minus 14 minus 18 equals to 0. If I take minus 3 as a common, then 3x 4x minus 3y, okay, and plus 3 6 are 18 equals to 0. I have taken minus 3 as a common. This minus becomes plus, this plus becomes minus, this minus becomes plus. And since 3 is taken common, 3 4s, 3 3s, 3 6. So 4x minus 3y plus 6 equals to 0 is this line. 4x minus 3y plus 6 equals to 0. The next question is, find the equation of the circle which touches the circle externally at 5 comma 5 with radius externally. That is the question given. And touch each other at the point of contact 5 comma 5. So we need to find the equation of the circle. Let us suppose that we need to find out this equation of the circle, and this circle touches x square plus y square minus 2x minus 4y plus minus 20 equals to 0. Okay, so we need to find the equation of this circle, and this circle touches this circle at 5 comma 5, and the required circle's radius is 5. That means if we know the center of the circle, then center C h comma k and radius r. What is the central equation of the circle? X minus h whole square plus y minus k whole square equals to r square. So that is why we need to find out this center. So how do we find this? So what is the center of the first circle? Solution. So given equation of the circle is x square plus y square minus 2x minus 4y minus 20 equals to 0. So if this is the circle, what is the center of this? C is equals to 1 comma 2. 1 comma 2. So what is the radius? Square root of g square plus f square minus c. So c is minus g minus f. Center of the circle is minus g comma minus f. So that is equals to here g square 1 square 1, 2 square 4 minus c, minus of minus is plus 20. That is equals to root 25, which is 5. Amazingly, the center of the radius of this circle is also 5. That means from this point of contact, this is equidistant. This point of contact is equidistant from the centers of the two circles. That means this is the midpoint, obviously. So the point of contact is the midpoint of the line joining of the center C1, C2. Midpoint of the line joining of the center C1, C2. So that is why. So point, let us suppose that P. Let P be the point of contact. Then P is equals to, P is basically the what? P is basically the internal center of similitude. So R1x2 plus R2x1 by R1 plus R2, R1y2 plus R2y1 by R1 plus R2. Here R1 and R2 is equals to same. That means that point, what is that point? Internal center of similitude will become the midpoint itself. Okay, so that is why P is equals to, so this is C1 is equals to how much? 1 comma 2, and C2 is, for example, alpha comma beta I will take. So comma, let C2 alpha comma beta be the, or h comma k you take, if you h comma k, C2 h comma k be the center of the required circle. Then P is equals to x1 plus x2 by 2, y1 plus y2 by 2. x1 is 1 plus h by 2, 2 plus k by 2 is equals to, what is the point of contact given? 5 comma 5. This is 5 comma 5. That implies 5 is equals to 1 plus h by 2. 1 plus h is equals to 2 5 is 10. There implies h is equals to 10 minus 1 is 9. And 5 is equals to y coordinate 2 plus k by 2. So 2 plus k is equals to 2 5 is 10. K is equals to 10 minus 2, which is 8. Therefore, C2 is equals to 9 comma 8. Therefore, the equation of the required circle having center CH comma K and radius R is given by x minus h whole square plus y minus k whole square equals to r square. X minus h comma k we found are 9 comma 8. So 9 whole square plus y minus 8 whole square equals to r is 5 square. So x square plus 9 square 81, 2 9s are 18x, y square plus 8 8s are 64 minus 2 8s are 16y is equals to 25. Therefore, x square plus y square minus 18x minus 16y. So 81 plus 64. So 1 plus 4, 5. 8 plus 6, 145 minus 25 is 120 equals to 0 is the equation of the required circle.